Alright, this is going to be Chapter 6, Drug Dosage Calculations, Basic Math, Part 1. And Introduction. Administering drugs would be much easier if they all came in the same form, same concentration, and were packaged in the same way. Drugs come in a variety of forms, packages, and concentrations. Everyone with the responsibility for administering drugs must be 1. Familiar with their various forms and concentrations, 2. Know how to prepare the drug for administration, and 3. Be able to calculate the dosage and the rate of administration. Packaged drugs often used in EMS, and there are multitudes of them out there. Every service is going to have a variation or a different variation of drugs. Lidocaine, furosemide, atropine sulfate, oxytocin, all of these drugs have a different concentration strength and are prepared differently and in different amounts of volume of fluid. You always have to be aware of, no matter what drug that you have, to take a look at the concentration strength of the drug. An example of this, let's pick furosemide here, and let's say that furosemide is 20 milligrams in 2 milliliters. Now, understanding that and knowing that that was your concentration strength, an example of this, let's say you wanted to give your patient 20 milligrams. Well, then I'm sure hoping that you gave them 2 milliliters. And we'll talk about this more and how to figure this out whenever it's not so simple. Whenever you have like half numbers and stuff, it's called volume delivered formula whenever we get to it. But every one of these drugs are in a different concentration strength. 3 systems of drug dosing, or drug dosages. There's the metric system, the United States system, and the apothecaries. And then we're going to have to know how to convert. We're going to get plenty of practice at this off of the blackboard and off of in course lecture. Conversions, we convert units into another system or convert units within another system. And the metric system is the first thing we're going to talk about here. It's an international system of units, or SI is the abbreviation for this, a standard system of weights and measurements used worldwide in science, medicine, and pharmacology. The United States uses a system called the customary system for household weights and some apothecary measurements. The metric system is a decimal system based on multiples of 10. All units are either 10 times larger or 1/10 as large than the next unit. Units of the metric system. For meters or length, we use meters for length, degrees in Celsius for temperature, grams for weight, kilograms, micrograms, milligrams, and liter or L for volume, liquid measurement. And there's a note on this that the symbol for liter is not a standard unit, but accepted unit of measurement in the US, Canada, and Europe. Common conversion factors, metric and customary. Examples of this, we'll get people that disagree with this, or not disagree so much, but give the wrong dosing due to this all the time. An example, 5 mils is equal to 1 teaspoon. 15 mils, tablespoon, 30 mils, 1 fluid ounce. An example of this where we could have problems. Let's say that the 2-year-old was supposed to have 7.5 mils of Tylenol, children's strength Tylenol, but mom gave him 1 teaspoon. So we are in all actuality about 2.5 mils short. And we're going to talk about this more, but this is just these are good examples of why we need to know this and why we need for all of these numbers and the conversions and whatnot to make sense. So 30 mils, fluid at 1 fluid ounce, 950 milliliters is 1 quart. 3.8 liters is a gallon. 2.54 centimeters is an inch. That's supposed to be INCH. 60 milligrams is equal to 1 grain. Now, we don't see that, thank goodness, very often, but occasionally we will get somebody that will administer something in grains. 0.45 kilograms, so 1 pound, and 1 kilogram, 2.2 pounds. Review of mathematical principles. Decimals are pretty simple. Adding and subtracting is pretty much, we just have to be sure that all of our stuff is aligned. Rounding decimals up or down. An example of this, rounding decimals up and down. Let's talk about the first one here for a second, as far as decimals and whole numbers. Now, what we get whenever we look at a decimal, and an example of this would be 1.5, is this right here is the whole number, and the 0.5 is the decimal. So this is half of one whole number. So 1.5 would really be equal also to 1 1/2. Adding and subtracting, as far as alignments, we got to be sure that all of our top numbers and our bottom numbers align very nicely. And rounding decimals up or down. Example 0.57. Well, in all actuality, this one right here, the 7, is greater than 5. So we could actually say 0.06. Another example of here down below, sometimes it's easier to see. This is a decimal point, so everything to the left of the decimal point is whole numbers. Everything to the right of the decimal point is partial numbers. And they go by spots. So the first number is tenths, then we goes hundredths, thousandths, 10,000ths, 100,000ths, ... and so on. Whole numbers the same way, units, ones, tens, hundreds, thousands, 10,000s, 100,000s, and so on. This is still a review of mathematical principles. Multiplying and dividing decimals, and they're essentially in multiples of 10. The placement of the decimal point determines the outcome. Examples of this would be, these are two whole numbers here, 10 times 10 being 100. This one here is different, 100 times 0.1, which this here is 1/10 of our, of 1/10 of one whole number. So 1/10 of 100, if we 10 times 10, this is 100. So very simply, we can easily just multiply this out. This has two decimal spots. 1 times 100 is 100. We have 3 zeros to add, and then 2 decimal spots. Decimal spots started here, 1, 2. So 10. We'll get some practice of that and do some of those in class. Same way with this one, 0.01 times 0.01. Well, we know in multiplication 1 times 1 is 1, and we have 1 decimal spot. So if we multiplied this by itself, or 1, then we would get the same amount. This one's a little bit trickier, that we have essentially 1 times 1 is 1, and we got 6 decimal spots. So 1, 2, 3, 4, 5, 6. I'll erase that, and you can see me do it to this one here. The decimal point was here before we started moving the decimal. 1, 2, 3, 4, 5, 6. So 0.000001 would be our answer. Review of mathematical principles. Ratio and proportions are very simply, we are just trying to reduce to the lowest common denominator, or the lowest amount. So 10 milliliters or 50 milligrams reduced to the lowest terms would essentially be 1 milliliter. We have 5 milligrams in 1 milliliter. And the easiest way to do that is, if we have a bunch of zeros, is just mark out the zeros. Many drugs are given in a solution, and the concentration strength, this is the basis on what we're going to be doing for dilution whenever we get to ed. But the concentration strength equals the amount of drug over milliliters. And what we essentially do on that is, once we know these two, how many milliliters of drug is going into and how much dry weight measurement is actually there, then we can figure out what our concentration strength is in milligrams per milliliter. Calculating the rates of infusion. Tubing. We have various kinds of tubing in the macro drip version. We have 10 or 15 drops per milliliter. Now what that means is that 10 drops out of this tubing is equal to 1 milliliter. So that means if we had 20 drops coming out of that micro drip, then we would actually have 2 milliliters. The 15 drop per milliliter version would be the same thing. 15 drops are equal to 1 milliliter. Now, most of the time whenever we do drugs and things like that, or we're dripping in medication, we're going to give it in the form of a micro drip. So 60 drops per milliliter is the one we normally use. Now, the nice thing about a 60 drop set or 60 drop per milliliter set is this, and y'all kind of follow along with me here. 12, 6, 3, 9. Okay, if this was a watch, and this was 60 seconds, and you put a drop in a second, in 60 seconds, 1 drop per second, how many drops would go in 60 seconds? Well, 1 times 60 is there would be 60 drops go in. Now, 60 drops, if we're using a 60 drop set, is equal to 1 milliliter. That means that we do 1 milliliter per minute on that drip rate, and saying that in 60 minutes, we're going to be giving 60 mils. Now, the point of this is that drops per minute and milliliters per hour are the same number whenever you utilize a 60 drop set. Now, why that's important is because we generally set infusion pumps into milliliters per hour. Temperature conversions, degrees in Celsius from Fahrenheit. We take the Fahrenheit and minus 32, multiply it by 0.556, and that will give us Celsius. Or get degrees Fahrenheit from Celsius, we take our Celsius and multiply it by 1.8, and then add 32, and then we'll get our actual Fahrenheit. We'll do some of those as well in class and on the blackboard. So in conclusion, when many of us hear the word math, we immediately have a catecholamine release or a release of adrenaline, sending our stress levels through the roof. The key to feeling comfortable with math is practice and practice. As with any skill, math requires frequent practice to maintain acceptable proficiency levels. In the next slide set, or part 2, what we're going to do is we're going to take everything nice and slow, put it into formula, do some math problems together, to where you can see nice examples of the actual equations being used. And this is pretty much a ratio proportion approach. References for this were taken from Beck Pharmacology for EMS Providers, Delmar Learning, pages 58 through 70, and Bledsoe's Pre-Hospital Emergency Pharmacology, 7th edition, Prentice Hall. If you have any questions, feel free to contact me. My name is Roy Smith, smith@imsa.net, or 405-219-7613. Thank you.